AI coding tools changed how software gets built. But for engineering leaders, one question is still unanswered. Is AI actually improving delivery, or just creating faster retry loops and more review rework? LoopLens gives CTOs, engineering managers, and platform teams evidence instead of intuition. It captures privacy-safe workflow signals from Codex, Claude Code, and Cursor, connects them to Jira, GitHub, and CI, and stores the evidence in AWS Aurora PostgreSQL. The architecture is straightforward. Collectors feed a Next.js API on Vercel. Aurora becomes the source of truth, and the dashboard and Copilot operate on the same evidence model. Inside the connected workspace, LoopLens shows the delivery system at a glance. Cycle time, AI-assisted work, collector coverage, CI failures, reopen rate, and cost per AI-assisted task. This is not a developer productivity score. The important question is whether AI-assisted work reached verified local green, survived CI and review, and moved real work toward production with less friction. The work graph connects planned Jira scope to the evidence produced during implementation. Here I can open Eng 418, an organization SSO callback, and inspect its complete delivery context. LoopLens preserves the original plan complexity, then calculates observed complexity from repository scope, pull requests, and validation activity. It also records AI attribution, confidence, and signals, and quality outcomes. And that means a manager can see whether an apparently fast AI task genuinely reached production cleanly, or whether the speed was offset by failed validation, review changes, or hidden rework. Sessions expose the inner AI development loop: attempts, failed validations, local green status, token confidence, and retry waste. Tools and models normalize these signals across Codex, Claude Code, and Cursor. Review outcomes then close the loop by showing whether AI-assisted changes were accepted on the first pass, required rework, or introduced issues after review. Together, these views connect the coding loop to the human review loop, without flattening everything into one score. The integration layer makes LoopLens operational. Jira supplies work item state and delivery stages. The installed GitHub app provides pull request state, review outcomes, merge timing, checks, and deployment evidence through healthy webhooks. Local collectors report AI workflow and validation events without uploading source. AWS Aurora PostgreSQL is the primary database for sessions, work items, connector health, and sync state. Every metric can show its source and confidence. Now, the AI layer turns those signals into an operating recommendation. I ask, what should we improve this week? Copilot does not return generic management advice. It identifies the evidence-backed bottlenecks: slow pull request pickup, repeated billing rework caused by missing regression tests, and costly retry loops in Cursor sessions. It then gives specific actions alongside the metrics that support each recommendation and an explicit confidence level. Finally, LoopLens draws a hard privacy boundary. It uploads structured counts, validation outcomes, fingerprints, and delivery identifiers, never source code, prompts, AI responses, shell output, secrets, or transcripts. LoopLens does not rank developers. It measures whether the AI-assisted delivery system produces verified, production-ready software faster, with evidence stored in Aurora.